Okay, so here we have the Calvin cycle, which occurs in the stroma. Calvin cycle begins with 3 molecules of RuBP. These RuBP molecules then go through carbon fixation. Carbon fixation involves rubicose, an enzyme, and CO2. Rubicose breaks the carbon off of the O2, off the CO2. The oxygen is released, and we're left with 3 free-floating carbon molecules. Then the rubicose attaches these free-floating carbon molecules to RuBP, creating a 6 carbon molecule. The 6 carbon molecule is then broken down by rubicose even further into 2 3 molecules. And these three carbon molecules are called G3P. G3P then goes through the process of reduction, which involves NAD and ATP. ATP is broken down into ADP, and the NAD is oxidized, releasing its hydrogen. The hydrogen attaches to the G3P, and the NAD and ADP go off, and the process repeats for every single one of our G3Ps.
Will my video be wrong if I had the building trees?
No, I'm not wrong. But just knowing.
You get it? Sorry, I didn't understand what you were saying.
I was just like, this has to happen 6 times to get 1 molecule. What time is
No,
you
it's
have to.
And then our last one, ATP breaking down, releasing hydrogen from NAD, and our G3P is now fully reduced. And after reduction, G3P turns into triose phosphate. So now we have 6 molecules of triose phosphate. One of these triose phosphate are set off to the side, and then these 5 triose phosphate enter the process of regeneration. So with regeneration, we use 3 ATP. The 3 ATP are broken down into 3 molecules of ADP, and the energy released from the ATP being broken down to ADP allows all of our carbons to be rearranged. And then our carbons are broken down into 5 carbon molecules, creating 3 5-carbon molecules. These 3 5-carbon molecules are our starting molecule of RuBP, and that is 1 turn of the Calvin cycle. But the process of the Calvin cycle is supposed to make a molecule of glucose. So these 3 RuBP go through the Calvin cycle all over again until we have the 3 triose phosphate again, or the 6 triose phosphate again. Oops. And once we have 6 triose phosphate again, the 5 triose phosphate go on into regeneration again, and that 1 triose phosphate that's left over attaches to the other triose phosphate that was left over from the first turn of the cycle, creating our 1 molecule of glucose. So we'd require 6 molecules of RuBP to go through the Calvin cycle to create 1 molecule of glucose, and that is the end of the Calvin cycle.